Good afternoon, everyone. This is Chris Bandazian. I chair the House Study Commission for Environmental and Health Impacts of Poly and Perfluorinated Alkyl Substances. At the moment, we have 11 members and need 12 for a quorum. So we'll pass over minutes. Representative Murphy will be joining us, I understand, in a few minutes. So at that point, we can go back to minutes. And so I don't believe we have any updates on commission membership. My understanding, unless somebody has other information, is that Ray Brislin currently awaits Senate President confirmation as a member, and he's invited to the meeting, but could not participate as a member. And we still have a Litchfield vacancy, is my understanding as well. So there are no additional information on that. We'll just move on to have Jeff Martz speak to us about soil contamination at the St. Gobain site. It's been many years since, at least at a public meeting, we've reviewed that information. There's a great deal of background, and obviously with the plant closure, it's very timely to revisit that. So please proceed, Jeff.
Thank you, Chairman Bandazian, and the rest of the commission for inviting me to speak. In preparation for this, I looked back, and it looks like I last presented to the commission in March of 2021. So it's hard to believe it's been about 4 years. I understand from Mike Wimsatt there may be a few new members here. So I thought I'd start with an overview of sort of what happened with St. Gobain, and kind of talk through sort of our conceptual understanding of some of the fate and transport of PFAS. So I'm going to go ahead and prepare my screen, and then I'll share it once I get everything set up here. Let's see, are you seeing my first slide?
No.
All right, so just to give you a little bit of background about myself, my name is Jeff Martz. I'm the administrator of the Hazardous Waste Remediation Bureau. Our bureau is the group at DES tasked with investigation and cleanup of contaminated sites, including St. Gobain. I started out at DES in 2018 as a hydrogeologist assigned to the St. Gobain project, a role Andy Fuller now holds. Once I became administrator approximately 3 years ago. Prior to that, I worked in private consulting for about 22 years in the field of groundwater protection and development. So this is just a view starting out showing PFOA across the state, with a blow up of the southern New Hampshire area, including Merrimack and surrounding towns where St. Gobain is located.
Jeff, I don't think we're seeing your slides, or I may be the only one.
Oh, you're not? Okay, bear with me one sec. Let's see.
The only one.
Okay, and I'll just note for the record that Nancy Murphy has joined us, and we now have a quorum at 12:08. I mean 2:08.
Let's see. So, Chris, you were the only one not seeing the slides, or is anyone else seeing them?
Not seeing them.
Not seeing them. Okay. Let me stop the slideshow for a moment. How about now? Are those slides up? Okay, perfect. So just to kind of review for folks who may not be aware, so St. Gobain is a manufacturing facility in Merrimack, located adjacent to the Merrimack River, and starting in about 1986, they began to apply Teflon and other coatings to a large roll of fabric at their facility. These fabrics were on spools, and the fabric went through a process of being dipped into a what we call a dispersion, which is a mixture of chemicals. Those mixture of chemicals, change depending on the product Saint-Gobain was trying to create, and the specifications for that. After the roll of fabric was dipped into the dispersion, it would travel up on a big sort of conveyor belt kind of situation through a vertically oriented oven, where it goes through various temperature zones to both dry and sort of adhere the Teflon and the coatings to the fabric. But through that process, PFOA and other PFAS were essentially driven off the fabric and emitted through a series of smokestacks that were located on the roof of the building. And that PFOA and other PFAS were transported with air and deposited on the ground surface as either wet or dry deposition, depending on whether it was raining or a dry day. And from the ground surface, the PFAS would leach into the soil and percolate down through unsaturated soil and eventually reaching the water table, where it could be drained by the pumping of various water supply wells. So at the facility itself, there are several different pathways and release mechanisms that result in the deposition of PFAS with various chemical profiles. So the main pathway that we're concerned about, why we're talking about Saint-Gobain today, is the air emissions pathway, where we had both particulate stack emissions, vapor phase stack emissions that would rain down on the ground, kind of represented by the little circles on this diagram. We also had cases where there were discrete spills of dispersion on the ground, and we also had discharges from leaky portions of the sanitary sewer line and the storm sewer line. And each of these PFAS that were deposited on the ground had different relative contributions of individual PFAS chemicals. So different percentages of, for example, PFOA or PFHXA that resulted in commingled plumes that we worked to untangle on the site itself. So there wasn't a single Saint-Gobain fingerprint per se, but rather a variety of fingerprints right on the property. Just to quickly review the timeline, in 2016, PFAS was first discovered in a water sample collected from a water fountain, which was public water provided by the Merrimack Village District, and that started the investigation that has been ongoing since. Also in 2016, US EPA issued a lifetime health advisory of 70 parts per trillion for PFOA and PFOS combined. Fast forward to 2019, we had a new effective date for 4 new PFAS HQS MCLs, so those were enforceable as groundwater standards and drinking water standards. And that's when we started with a regulation of 12 parts per trillion for PFOA. Several parties filed suit against the state for this standard, and it was effectively blocked until July 2020 when it was passed and adopted as a matter of law. And then from a regulatory standpoint, most recently in December 2024, we have PFAS soil remediation standards that were adopted in rule. In the second part of my presentation, we'll get into that in more detail. So this is a figure showing a representation of modeled air deposition of PFOA across a 14-mile model domain. The main yellow area to the right is the Saint-Gobain area. The smaller yellow area is TCI and Amherst. And this is a special color stretch that we use to illustrate the logarithmic or nonlinear deposition of PFOA. In other words, really great amounts of PFOA were deposited in the bright yellow areas that diminish rapidly as you move away from the facility to the reds, the blues, and the cooler colors. So much less PFOA is thought to have been deposited once you get far from the facility, but it's still a significant amount in that it has resulted in widespread groundwater contamination. And nowhere in this model domain was the model indicating a zero deposition for PFOA. And these models were initially used early on in the investigation as a guide for groundwater sampling. And as might be expected, some of the highest concentrations of PFOA in groundwater were centered in some of the areas with greater air deposition. And throughout my talk, I just want to call attention to the color ramp that I'm using for PFOA. We have 0 to 6 parts per trillion for shown in green. Groundwater samples that are 6 to 9 are yellow, 9 to 12 orange, and between 12 and 70, which is over our AGQS for PFOA, are shown in red, and anything over 70 is shown as purple. In 2018, Saint-Gobain and the state entered into a consent decree which defined the 64 square mile area, which encompasses thousands of water supply wells, both public and private. And this has been an area of focus of DES in ongoing regulation of Saint-Gobain through our contaminated ENBOR 600 rules. One thing that's important to note is that the PFAS emissions are thought to have changed considerably over time. So this is a bar plot showing the estimated emissions from Saint-Gobain in pounds per year. So starting on the left-hand side in 1986, it was estimated that about 100 pounds per year were emitted from the facility. Moving up to 2005, they continually added to their process and added more product lines and had a peak of approximately 900 pounds per year emitted in year 2005. Shortly thereafter, the manufacturers of PFAS reformulated, and a lot of the feedstocks that went into the dispersions that Saint-Gobain used had greatly reduced amounts of PFOA. So starting in 2007, the estimated air emissions from the facility was about 12 pounds of PFOA. So a significant reduction from just 2 years prior in 2005. So there are many factors that influence the occurrence of PFAS in groundwater. One is the bedrock geology. There are examples where what we call the lithology, so that's the rock type, seems to play a part in some of the concentrations that we see. This is a geologic map showing the bedrock throughout the consent decree area. And also we have structural geologic features, such as some major fault zones, which are indicated by these dash lines. We have at least one neighborhood that where the fault transects, and we have a lot of PFAS groundwater data that suggests that the fault does have some control on what we see in terms of PFOA concentrations in groundwater. As many of you probably know, the state was glaciated, covered by a thick continental glacier a little over 10,000 years ago. And that glacier really informs what we see on the ground surface today through a series of glacial deposits, which include glacial tills. We have lakebed deposits over in Litchfield, which are thinly layered fine sands and silts. And then most notably from a water supply standpoint, we have some important stratified drift aquifers, particularly notable in Merrimack, where the MVD derives, I believe, most, if not all, of its water from groundwater stored in these stratified drift sand and gravel aquifers. This slide speaks to the variability of PFAS concentrations in certain bedrock wells over time, another important concept. So at the time I generated this slide, we had about 9 bedrock water supply wells that had been sampled at least 4 times. And I plotted the high concentration in blue for each well and the low concentration in red. And one pattern that emerged based on the data from these 9 wells is that the lowest concentrations tended to occur in almost all cases when groundwater in the aquifer was at a low point. This low point typically occurred during late summer when there was not a lot of recharge to the underlying aquifer. But we tended to see the lowest concentrations of PFOA at that time. And conversely, when there was a higher water table, we tended to see higher concentrations of PFOA. And I have another slide that I might be one possible explanation for what we see here. So in summary, kind of the complexity that we see in the spatial distribution of PFAS in groundwater is a function of many different variables, including variations in the air deposition across the area, a combination of the superficial geology, the bedrock geology, as well as those time-related factors such as changes in what chemicals were used and released over time, and the seasonal variability. So one question that we get frequently is, why do neighboring wells have different concentrations of PFOA? So to answer that question, came up with a slide that shows two bedrock wells, the two wells on the left-hand side of the cross-sectional profile, and one overburden well. So just to refresh everybody's memory, a bedrock well derives groundwater from fractures in the rock. So the photo on the left-hand side was taken with a downhole video camera and shows cracks in an actual well bore with water pouring into the well. So going back to my cross-sectional view, the bedrock well on the left derives its water, hypothetical well, derives its water from fractures that are relatively shallow and connected to an area that is overlain by just a thin layer of soil. So the blue lines are representing water-bearing fractures. And these fractures are getting water that recharges with only a little bit of passage through soil, so there's not a lot of opportunity for the PFAS to stick to the soil. So in this example, the well on the left is over our ambient groundwater quality standard for PFOA. Moving to the right of this figure, the next bedrock well penetrated through a deeper segment of soil, and in this scenario, the soil, the thicker column of soil sorbs some of the PFAS. So we have an intermediate concentration of PFAS going through the shallow fracture. And then there's a deeper fracture that represents water that may have recharged into the ground or entered the ground before Saint-Gobain was operating and has low or no concentrations of PFAS. So the mixture of that water results in this case, a 6 to 9 part per trillion concentration. And then we move a little further to the right, we have a shallow overburden well, and that is pulling water from that shallow overburden that in this example would be over AGQS. So this is sort of the halfway point before I move into the next part to talk about soil remediation standards. And I can either take questions on what we just covered, or we can move on to part 2 and take questions at the end. Representative Murphy.
Oh, thank you. Thanks, Jeff. Just, I had some audio issues in that the very first slide. Can you tell me what that small yellow area denoted? There was Saint-Gobain was on the right, and there was a smaller yellow area to the left. Was that the landfill or?
Let me just flip back to my slides
one of your first
here.
slides.
I think it was TCI in Amherst.
Oh, it might have been.
Oh
TCI.
yeah, that would have been TCI
Okay.
on the sort of blue and yellow
Yes,
figure.
yes. Okay, thank you.
Yeah.
Yep, that's all. Thank you.
But as long as we're on that slide, I've got a question.
Sure.
For the and this is Wendy Thomas. I had to go off of webcam for connected issues. For the map of the consent decree, is that a snapshot that was taken? I don't understand the boundaries like that. Is that a snapshot, or is that some sort of over time, these are the areas?
So what we see here, if everybody's still seeing my screen, this is the actual boundary of the consent decree. And the underlying colorized, I would call it a raster map, but the underlying color is an image of the addition of 2 modeled air deposition models. So they represent some unit of PFOA per square meter. And then it's interpolated sort of using these colors. One thing that's important to note about this air deposition, and I think I did this for, let me see if I can go back one slide. I don't know if I mentioned which, I think I did this for the peak year. It was either the peak year or the sum of all years. I don't recall. But essentially, well, there's a lot of inputs to the models, and some of those inputs are highly uncertain, and they affect the actual numerical value that comes out of the model. So I think it's hard to say with any level of confidence how many grams of PFOA were deposited on any square. But I think what this model does represent, and I think it is informative, is that it shows at least the relative amounts. And I think the model is validated to some extent from the variability we see in groundwater tends to follow the pattern of air deposition, in that we see higher concentrations in wells in these areas that the model predicted a greater amount of air deposition. But just be aware that I think to say what the absolute amount of air deposition was, I don't think the models are particularly good at that.
Okay, so as a follow-up, that map was based on air models and not on soil or water testing?
That's correct. What the colors in the background are based strictly on the output of 2 air models.
Okay, thank you.
But I will say some of the soil testing conducted by Saint-Gobain also sort of bears this out. And you know, in terms of the entire model domain, we have a limited number of soil samples, but at the facility, you know, we have some fairly detailed soil sampling, which indicates, you know, in some cases, concentrations that are over our direct contact risk-based value. So that's a threshold above which we would expect, you know, potential, you know, for concern from a health standpoint. And I could talk a little bit more about that value, what those values are, when I get into part 2.
Rosemary, you have your hand up.
Yeah, and I see Lorraine's too. Thanks a lot, Jeff. A question I have is, when you're talking about the percolation of the PFAS leaching out of the soil, do you see a big difference between the adsorption properties of PFOA relative to other PFAS, and how that may impact it traveling through the soil into the water?
Yeah, so that's a good question, and we do in fact see differences between different compounds. So PFOA moves more readily through the soil column than, say, PFOS. And then we have, in the case of Saint-Gobain, some even longer chain compounds like C10, 12, 14, and those, you know, move very little through the soil. So we tend to see those in shallow soil and at a very limited extent in perhaps some of the most contaminated groundwater wells on the property, but you know, we don't see those typically in you know, domestic water supply wells. So there is a great deal of variability from PFAS to PFAS.
Yeah, because follow up, Mr. Chair.
Sure.
So, because I remember years ago, I had asked you if we were able to get like a fingerprint of contamination based on the profile of the different compounds in groundwater and perhaps with soil, but we really wouldn't be able to do that because of the different adsorption properties, correct? So
Yeah,
yeah, like we wouldn't be able to say, oh, this contamination came from TCI, this came from Saint-Gobain, this might have come from, you know, firefighting foam. You wouldn't really be able to do that then, right?
I think you can make certain discerning. I think you can look at data and say that this looks like something from Saint-Gobain, especially when you get into water supply wells at lower concentrations. Like, you know, that typically, the typical, I guess, Saint-Gobain signature, so to speak, would be, you know, primarily PFOA with lesser amounts of PFHXA, PFPEA, and a little bit of PFOS. We did have emissions of PFOS out the stacks. But when you move closer to the facility where we had higher concentrations of all these chemicals emitted, there's actually, if you break it down, several different fingerprints, so to speak. And I think that partly speaks to the change in the formulation that occurred in, you know, the 2006, 2007 timeframe. So We have some samples of some deeper monitoring wells that are primarily PFOA dominated. So PFOA would be the highest concentration of any PFAS detected in that particular well. But we do have at least 1 or 2 monitoring wells that, and I would say that water entered the ground pre 2007 timeframe. But then we do have some monitoring wells where we actually have more PFHXA, so that's the C6 carboxylic acid. We have more PFHXA than we do PFOA. So I would say that is primarily a mixture of groundwater that entered the ground after Saint-Gobain reformulated in that time period where they're only emitting 12 pounds of PFOA. So I think there's this mixture that as hydrogeologists we can try and untangle the time period based on those changes in dispersions, and then you can have all kinds of mixtures with different ages of groundwater, in a single sample from a well.
Okay, thank you.
Thank you. Go ahead, Lorraine.
What interests me about the air modeling and then the graph that showed the poundage use is when I saw the drop off in 2007, is that poundage use per year of PFOA only self-reported by Saint-Gobain? Or because I know when we did the stack, emission, laws in the last few years, there was more ability to verify and measure things that were being emitted. So was that self-report, the poundage per year?
I will admit that slide was provided by Kathy Beam's group, who did the air modeling and worked on the air models and took a closer look at the dispersions. We certainly communicate very closely, and work together on the site investigation side. But I believe that was essentially information reported by Saint-Gobain. I think they're the only entity that had records. So in some fashion that had to be reported to us.
So I don't know if you know this, but we've talked about this a few times at commission meetings here and there as an aside, is that, in the deposition and the discovery of the Hoosick Falls Saint-Gobain lawsuits came this revelation that the poundage of PFOA in Merrimack was in fact not accurate. And they really admitted it it's all there in the discovery that it was significantly more than reported. And when I heard that, and it's been verified and it's been out there for a while, some of the folks here have said, geez, that gives us grounds to kind of reopen the consent decree. I know you don't have the authority to guarantee us that. So don't worry, I'm not going to put you on the spot. But when I think about that, there's a few things that really do trouble me. So I just want people to keep this in mind. One is it was self-reported. 2 is it's on record that it wasn't the truth. It was an absolute lie. And 3 is Gen X is a substitute for PFOA. Gen X did not receive a consent of use permission by the EPA till 2009. So I find it really hard to believe that from 2007 to 2009, they pivoted to some interim, chemical compound. I just don't believe that. And then my other thought says, did DuPont lie and say, yeah, we didn't use Gen X till after we had permission in 2009. They were really moving it earlier. I doubt that. I think this really speaks to this model is great. What you've done in mapping and stuff is valid and very impressive. But the data that was used to establish this consent decree and everything there is based on that slide. Just reiterates to me that it's not true. There is not a chance in the world that they dropped off, from 2006 to 2007 to that extent. I think they conveniently reported that in their own discovery. It's right there that they in fact did not. So, you can't give me what I want. I know that, but we really feel strongly, in this town and in this commission that, there's just another glaring piece of who's been driving the show here by self-report. And whatever we can do about that, I don't know who we have to pressure, because it's, this whole story has been, injustice after injustice and so many rights that we should have that we don't have. But there is a glaring piece that I really feel that we should be able to go back and apply what was learned in discovery in New York. It's all on record. It's well cited. If we plug in that data to these air modeling maps, what are we going to get with the accurate usage? And then what does that look like? And maybe that gives us a little more power and saves us public dollars, you know, because public dollars are the grant program, and there's many gaps here that we're filling with public dollars, and they have not really had their feet held to the fire. So I don't even know if you can comment on all that, but that's my 2 cents worth about that when I saw that graph of, you know, pounds per year drop off to that extent.
Yeah, the only thing I can say about the air model, and first and foremost, I'm not an air modeler, but you know, I've talked to the folks who did that work, and one of the major factors that influence the output of the air model is what we call the particle distribution size, and that was never measured for one reason or another at Saint-Gobain, so they relied on particle distributions from other facilities, and depending on which one you used, you got very different numbers on the ground. So that's why, you know, I think we use the air model as a general guide for a pattern as opposed to an absolute value that was deposited on the ground. You know, I think from my standpoint, I'd like to see, you know, soil data, groundwater data, you know, to try and quantify what is there. And so I don't think the air model, you know, even if we had a poundage, you know, an exact value, I'm not sure that we could still predict what was deposited at any point to any degree of precision. You know, I think you could estimate it, but I don't know if that would change the model as much as this particle distribution, but again, I'm not an air model.
And you know, we see C3s to C6s everywhere, not just here, but of course they're everywhere, and we keep the focus on, you know, PFOA. So it's difficult. It's difficult.
Any other questions for Jeff at this point? If not, Jeff, why don't you go to part 2?
I see Mr.
I'm sorry,
Patrick.
I missed
Thanks.
you.
I appreciate that. Yeah, I was just kind of go along the same lines as Laureen is, you know, again, with the falsely reporting strength of the PFOA, I'm a believer of any air model is going to show a larger dispersion area, a larger impact area with a larger concentration of PFOA. So I don't know if you agree or disagree with that, or if the air division ever considered that. I guess it's more of a statement that I'm making. And then when the graphs of the PFOA and how they declined based on the self-reporting, I believe, I'm kind of surprised. So I guess I'm assuming that the PFOA self-reporting was just something that was not required on behalf of Saint-Gobain. And I don't know if you know the answer to this, but it begs the question, if they were required to self-report the PFOA, and then they kind of stopped using it essentially, or used very little of it after 2005 or 2006, whatever they used to replace that, the slide said that there's no information on it. So I'm kind of questioning, why were they reporting the PFOA but not the replacement chemicals? That doesn't make sense to me. So again, I don't know if it's maybe more of a statement than a question. But the other thing is, I think ChemFab was the company that preceded Saint-Gobain in the 80s, because Saint-Gobain only moved here in the early 2000s, and they took over operations of ChemFab. But I think you're right. My recollection is that the predecessor company was already doing air emissions of PFAS on their own. So, you know, whether Saint-Gobain bought those emissions because they took the company over or whatever, but the fact of the matter is, if it did start in 1986, then, you know, it certainly has it probably went to a larger area of deposition because it was, or more concentrated on the ground because it lasted longer, essentially. So, but that was really just the points I wanted to make. So thanks for that.
Yeah, yeah, you're correct. So ChemFab started in '86, and then Saint-Gobain purchased them. I forget the exact year that they purchased them, but you know, I think some of the original equipment stayed there, and then they added. My understanding is they added more towers and whatnot, and expanded, you know, and essentially built up the total emissions. To the extent that they were required to report, I can't speak to that. I don't know if they reported any of this, like year by year, or if this was all reported as part of the investigation. I don't know the genesis of that information. You know, DES does have material safety data sheets. It's something that's protected by confidential business information. So it's something, we have to keep not we have to keep private. But I think one of the things that they switched to was Gen X, which is something we have looked at in groundwater. We've sampled wells for it, and aside from primarily monitoring wells, and with maybe one or two exceptions, we don't see Gen X in groundwater to any great degree. I think it's in the tens of parts per trillion in on-site monitoring wells. That would have thousands to tens of thousands of parts per trillion PFOA. So, we just don't see it in groundwater to any degree. And in talking with the folks at EPA ORD, we work with them early on to evaluate what we might not be seeing with conventional laboratory analyses. They did some non-targeted work, and I think I recall some of the chemists saying that they thought that the Gen X may have converted to something called E1, which my understanding is that that's like a gas, and I think that's why we're not seeing it in groundwater, as Gen X.
Oh, Tanya, go ahead.
Thank you. I have a question because I'm living in Salem, so there's two open water sources, Canopy Lake and Arlington Pond, and you're talking a lot about groundwater. I'm curious to see Canopy Lake has both of Canopy and Arlington Pond have PFOAs and PFOS that they're monitoring. What's the spread of this type of contamination, and it's traveling down across all of New Hampshire? Have you been testing any of the open water sources?
I know there have been some folks at DES that have tested surface water, and there's been some studies. So there are surface water data, and you can actually go onto our PFAS viewer, and I believe that surface water data is available on that public viewer. So if you wanted to take a look at a particular water body, you should be able to see if there's a surface water sample.
I apologize. I mean the Gen X that you're talking about. Have you to see how far did it travel down on open water surfaces?
I don't recall seeing Gen X in any surface water. I haven't particularly analyzed for Gen X in surface. I haven't analyzed the data set that we have for Gen X. I was primarily focused on groundwater and drinking water in the greater Saint-Gobain area. But I haven't come across any reports or discussion of people finding Gen X in surface water bodies.
Yeah, I don't recall from the fish sampling study whether Gen X was one of the compounds that was looked at. I think maybe if we go back to that, it might be. And there were one or two ponds in the area, but not Canopy Lake or Arlington.
Yeah, I can't recall from the fish testing if they analyzed for Gen X and it wasn't found, or they didn't analyze for it. I'm not certain.
But I think
My understanding is HPFODA, which is Gen X, once it hits water, once it hits even blood, it changes into other compounds that are all in the category of concern, but you're not going to see that in its pure form, which is why it's very desirable to industry if you can't track it from cradle to coffin, as they say. So we have to keep that in mind.
Okay. Any other questions for Jeff at this point? Okay, if not.
Let's see, I do have the second slideshow, kind of part 2 on, I can tee up for the development of soil remediation standards. All right, so if everybody's seeing my screen again, so this is part 2. Going to just run through how we came up with the soil remediation standards. So as you may recall, RSA 45H13 was enacted in July 2022 that directed DES to start rulemaking to develop soil remediation standards based on leachability and other factors. for the 4 compounds that we regulate in groundwater. These soil remediation standards went into effect December of 2024, along with some other changes to our contaminated site management rules. We have a methodology that we followed for the development of other soil remediation standards, and that's laid out in our RCMP. I think there were some links that Chairman Bandazian sent out to the report that documents all of what I'm talking about today, if you want to see those. But in a nutshell, basically the process involves reviewing 5 factors. So that's calculating the direct contact risk-based value that I talked about near Saint-Gobain, where we have some violations of that. Calculating leaching-based values, identification of natural background values, identifying what laboratories can actually measure in soil samples, or the estimated quantification level, and identifying a sealing concentration, which is often like a vapor threshold for chemicals you might inhale. So for PFAS, this sealing concentration doesn't really apply at the concentrations we're talking about. It'd be quite a bit higher. So recognizing that PFAS behave differently than other chemicals in soil, and it was developing science, we partnered with the USGS to conduct a study across the state on what the occurrence of PFAS in shallow soils were, and to evaluate some of the factors that influence the partitioning of PFAS from soil to water. And just want to acknowledge Andrea Takranov was the lead USGS investigator on this team, and we had several folks from NHDS. So in a nutshell, we broke up the state into 100 equal area grids and selected locations in each of these grids not thought to be influenced by nearby contamination sources, and collected soil in undisturbed areas from 0 to 6 inches in all 100 cells, and then in 6 to 12 inch intervals in a subset of the 100. And then in a smaller subset yet, we collected a deeper soil profile, which I will talk about in another slide. This is a bar and whisker plot showing the concentration of the most commonly detected PFAS as in that 0 to 6 inch interval. So just note that the vertical scale is in parts per billion or nanograms per gram, and it's a logarithmic scale. The blue line that is flashing represents 1 part per billion. And at the time we did this study, most commercial laboratories could not detect concentrations below this line. But the USGS worked with their contract laboratories to get really low detection limits to really evaluate what was in soil across the state. And these bar and whisker plots show the distribution of the data. If you're not familiar with the bar and whisker plots, the dark line, bold line in the center of each of these boxes represents the median value. Half of the sample results for a given compound are above that median, and half are below. I've highlighted the 4 compounds that we regulate, so PFOA and PFNA on the left. And you can see that the median value for PFOA is around 0.73 or 0.76, just below that 1 part per billion level. Whereas PFHXS is approximately 0.5 parts per billion for a median, and PFOS is almost exactly 1 part per billion. So this is sort of the distribution of what we're seeing in those 100 shallow soil samples across the state. We did have some detections of Gen X, but they are quite low. Most of the results were below 0.05 parts per billion. So some really low values for Gen X in soil. So this is a map showing the distribution of PFOA and PFOS in shallow soil. PFOA is on the right, PFOS is on the left. The blue cooler colors are non-detect to 0.2 parts per billion. And at the top end of the scale, the red is greater than 4 parts per billion. And I think if you spend some time and look at the distribution of PFOS in soil across the state, you see somewhat of a random spatial pattern with some highs in the north central part of the state as well as the west. If you look at PFOA, there's a general trend of lower concentrations of PFOA in shallow soil in the northern part of the state, increasing to higher concentrations in the southern part of the state, with one of the higher values. I believe that's maybe New Boston, just northwest of the St. Cobain area. But there is a variability within within a latitude of the state, so there is some variability, local variability in PFOA across the state. So I mentioned we did some deeper soil profiles at 6 of the sample grids. And one of the key takeaways is that most of the PFAS detected in soil, these are sums of PFAS in parts per billion on the left, in picomoles per gram on the right. But what this chart shows is that most of the PFAS was confined to the upper foot of topsoil. And as you go deeper in a profile in an area that's absent a major release, you don't find very much PFAS. Now, this is in contrast to what we see in the greater St. Cobain area, where the center of mass of PFOA is on average, approximately a foot below ground. So there's like a leaching front of PFOA, probably reflective of that change in dispersion use in 2006. So, a lot of PFOA was deposited prior to 2006, and then that has leached down through the soil column. And if you did sampling at different intervals, you could find some fairly high concentrations at even greater depths, depending on the soil, depending on the location at the St. Cobain area. So one thing as part of this soil remediation standards is that we developed a leaching-based concentration that's protective of some of the most vulnerable groundwater. We selected a model that evaluated some of the leaching parameters that USGS identified in New Hampshire-specific soils, and we developed a leaching-based value that's protective of groundwater and a release in stratified drift, a soil that wouldn't have a lot of organic carbon. And this is a slide that briefly describes the model. The model is essentially, after reviewing a bunch of different modeling options, we settled on the model that we've actually used for other chemicals that we developed SRS for over time, and that's called sea soil. And also we found that the subsurface release scenario resulted in a more protective leaching-based value. So that's a release or a source that's a meter below ground, and kind of as shown in the upper right, the cross-sectional view. And we did look at what type of values we might get from modeling an air deposition source, and that was a less protective value. So a higher concentration could be deposited on the ground surface and still protect groundwater. And I think that's reflective of factors such as organic soil, organic carbon content of that upper soil might capture some of that PFAS and retain it for a greater period of time in that soil. We did not identify a single background value for a couple of reasons. One, there's no natural occurrence of PFAS, and two, there's quite a bit of variability from sample location to sample location. So if setting one value for the state probably wouldn't be protective in certain areas. We did calculate a background threshold value, which can be used as a screening tool when you're evaluating whether some concentration of PFAS in soil is related to a release or if it's some form of background. So after we identified the factors that we identified, we went through this selection matrix and then came up with the soil remediation standards. We took the lesser value of the measurable level from a laboratory and the leaching value. So in the case of PFOA, PFNA, and PFHXS, the SRS are based on the laboratory detection limit coming out of EPA's method 1633, which was finalized while we were doing this work. And then we used the leaching value of 0.5 parts per billion for PFOS, which was slightly greater than the estimated laboratory quantification limit. So again, for PFOA, we had a 0.4 part per billion SRS, and the highest SRS was for PFNA at 1.3. So that's a very quick summary of the work we did to derive those soil remediation standards.
Okay, Rosemary.
Jeff, this was a phenomenal presentation. I need to digest some of the science a little bit more. It's coming out fast. Is there a way you can make these slides available on the website?
Yeah, I think we could. I don't know if I could put them on the web, but I could certainly very easily transmit them to Chairman Bandazian for distribution to the group. And you know, if you really want to dig into the values or what I just presented, there is a technical report that Chairman Bandazian, I believe, included as one of his emails coming into this meeting. And that goes into each of the 5 topics in some level of detail. So that might be something you could digest in conjunction with the slides, you know, depending on what degree of depth you want to go into this.
Okay, thank you very much.
Sure.
I have a question.
Okay, I did not see who that is, but go ahead.
Okay, thank you. So I understand you did the soil sampling sort of as a survey, but do you do any proactive soil sampling like around landfills or other corporations or anything like that?
So we've requested that certain contaminated sites do soil sampling, and up until this point, that's been fairly limited to types of releases where we think there may be reason to believe that they're over direct contact values, because we didn't have a leaching-based value until just December. So most of the other types of sites where we have soil data, aside from St. Cobain, are places where AFFF has been released, or other very high concentrated releases of PFAS. Because if I go back a slide, you can see that in contrast to the leaching value, which is 1, you know, on the order of 1 part per billion or less, the direct contact values don't come into play until you get to 100, and in certain exposure scenarios, even up over 1,000 parts per billion. So a very big difference. But I can tell you from having looked at a number of sites with groundwater data, you know, if you're in the tens of parts per billion, you've got a pretty significant groundwater contamination issue. So, you know, unless we were looking at AFFF or just major releases, we haven't asked for a lot of soil data. But now that we have leaching-based standards, you know, we're beginning to look at sites to request soil sampling, you know, where it would inform protection of human health and the environment.
Thank you. I have a follow-up question also, if that's okay.
For a record, it's Wendy Thomas, right?
Thank you. Yes, I'm sorry. Yeah, I'm off of camera. Throughout this entire presentation, you kept referring to St. Cobain's self-reporting amounts of chemicals and self-reporting error models, that kind of thing. Is there any kind of a procedure for validating self-reports?
Yeah, I guess just to clarify, I believe that the models that we showed here today were conducted by DES staff. So that was modeling that was done by DES based on some information, you know, provided to the department. You know, I think St. Cobain may have done their own independent modeling. They've done some additional modeling where they take the air model and then factor in some leachability and groundwater, and you know, they presented those to us, and that's something I reviewed early on. So, you know, we do review what they've submitted to us.
Maureen?
Okay, thank you.
Is there a plan to take this work and implement it in a regulatory fashion, or is this something you need some further rulemaking from the legislative bodies?
So now that we have enforceable ground standards that are protective of groundwater, we intend to you know, begin to implement this in some fashion. You know, we're given the scope of you know, this project and the aerial extent, that's something we're continuing to look at. But you know, just very recently we issued a letter to St. Cobain reference a property that had generated some excess soil as part of a construction effort. And we asked St. Cobain to address the excess soil that contains high levels of PFAS. That letter should be up on our one-stop, you know, if folks want to take a look at it.
So when you say ask them to address, they're going to come up with some sort of a report or plan on their own, then it gets reviewed, then all of that kind of stuff. So is there going to be a penalty, or how much clout do you have, I guess is what I'm saying, to enforce, and this is about remediation and cleanup appropriately?
Yeah, so we have you know, a series of rules now that you know, address contaminated site management, and we have some underlying statutes. So it's the combination of those rules and statutes that guide what we, you know, can ask Saint-Gobain to do in conjunction with the consent decree. But the consent decree, you know, I think largely speaks to the 600 rules, falls back to the 600 rules.
Tanya.
Thank you. So you mentioned earlier that, you know, a lot of these contaminants are found within the 1st foot of the soil. Has anybody done any work on understanding how much goes into, you know, just growing vegetables? I mean, is it showing up in vegetables? Are farm stands all of a sudden being taxed with something that, you know, they're selling contaminated food?
I know some folks, some risk assessors have looked into to vegetables. You know, it's not something I regularly look at, but my understanding from some of the work they've done is that there's a great deal of variability in terms of which PFAS are taken up by various plants and the type of plant, and in some cases where in the plant those PFAS reside. So I think the answer is it's not an easy you know, you can't summarize it in one fell swoop, but Jonathan Patali, when he was the risk assessor here, did work on some studies to evaluate that. But I just don't have the knowledge to speak much further on that topic.
Follow up? Do you know of any studies that we can read that maybe other states have done?
Not off the top of my head. You know, I've read stuff that comes through my inbox. You know, I get you know, a lot of information on PFAS, but certainly you could Google PFAS and food and vegetables to probably get up to speed on the most recent science. You know, I don't know to the extent ITRC has addressed this, but I know we often turn to ITRC for some of the latest compendiums of science on leachability of PFAS in soil, groundwater, surface water. So they have a large document that they're continually updating. So you know, you may look at and see if ITRC has summarized any of the information on uptake to plants and whatnot.
Don? Oh, I'm sorry. Yeah, go ahead, Don, and then Maureen.
All right, thank you. Thanks for the presentation, Jeff. So I believe I understand that the EQL numbers for the first 3 PFAS there are what actually establishes the soil remediation standards. And it looks like PFOS is the only one that the actual leaching rate is what, leaching value is what establishes the soil concentration limit. Now, from what I understand is that 0.5 is parts per billion. So I guess if you back up to the prior slide, if you can do that for me, I think it was the previous one. Keep going. It's the one that shows the cross section of the, yeah, that one. So the way I understand that is that what you're saying there is the source of contamination in that 10 meter square, a concentration in that soil of PFOS of 0.5 parts per billion will end up generating PFOS in groundwater in that well at 12 parts per trillion. Is that correct?
Basically, yeah, that concentration of PFOS in the soil would result in an ambient groundwater quality violation at the what we call a receptor well, which is 10 meters or approximately 30 feet away from the source area. So the model sort of had 2 components, had the leaching component and then a groundwater flow and transport component to it. So basically, it would calculate the concentration at the receptor well and then sort of back out what concentration of soil would be protective of that groundwater at the receptor.
So if you look at that well is 10 meters away from that source of in the soil, Is it true to say then there's some dilution of that concentration that ends up in the well, so that there's actually a higher concentration in the groundwater directly below the source that gets diluted down further by the time it gets to that well?
I believe this may bring in some component of dilution, but I'd have to review some of the model parameters to really answer that question definitively.
Yeah, and I guess that was a question I've had on this in the past. Is I'm really questioning what the purpose of a 10-meter well is 10 meters away from the source when the groundwater is actually over the ambient groundwater concentration directly beneath the source. But then when you move 10 meters away, it's actually exactly at the ambient groundwater quality in the well. Wouldn't it be more protective of groundwater to just throw away that receptor well and look at what the PFAS concentration is in the groundwater beneath the source? Because in reality, that 10-meter square is like hundreds, if not thousands of feet. It's not 10 meters. So this really is no 10 meters away from the concentration that, when you have the vast contaminated soil that we see, especially around the Saint-Gobain site itself. So I still just have a hard time I'm pretty sure I reviewed all of this when it was being proposed, and there is some matter of dilution, and there may even be some attenuation onto the soil particles in the groundwater table that diminishes the PFAS concentration as it travels away from just beneath the source. So if it ends up in the well at the ambient groundwater quality standard, when you back that up to right below the source of the soil itself in the groundwater, that would be higher than the ambient groundwater quality. And you'd have hundreds or if not thousands of these little boxes all over the whole site. So it's really, in my mind, I don't think it's protective of the groundwater. Now, I understand, in the cases of all but PFOS, it's the quantitation limit. So, but not knowing what the actual leaching number is beneath the soil contamination itself in the groundwater, I kind of wonder if what those numbers are, and if that's more representative of what the real leaching limit in the soil should be. But it's just a statement. I just want to point that out.
Yeah, and I think this model may have been conservative in the standpoint that I don't think it assumed any additional leaching once it was moving in groundwater, which may or may not be the case in reality. I'd have to go back to some of the assumptions that went into the modeling, but I can say that this is the model that has historically been used to develop the soil remediation standards with some tweaks for PFAS and the inputs here. I think typically it was to test the scenario of a nearby water supply well, because typically you wouldn't put a water supply well in the middle of a known source of contamination. And I think that's the theory that went into the development of the model. But I think in reality there would be some higher concentration right when it hits the water table, the leachability, and then a certain amount of dispersion and dilution that does go on. But I think where these numbers are driven largely by the quantitation level, we're pretty low in soil right now.
Yeah, thanks.
And also, interestingly, we did look at the size of the area, and so we had a consultant look at different modeling approaches, and they varied all kinds of variables and looked at the resultant outputs. And when you made this bigger, it didn't necessarily change the value or concentration in soil that would result in a groundwater violation. So because I think my first question was like, geez, we got this scenario where tens of square miles plus have been impacted. How does that influence it? And it's actually the subsurface 10 meter by 10 meter release is more protective than a large surface release.
Other questions for Jeff? Laureen?
So with PFAS, everything is connected, and I always like to think of it as the goal is to have a holistic, integrative response. And when Tanya was asking her questions, they were really important. And I'm wondering if with these soil values, clearly it's been all, conceptualized as relating to groundwater contamination from soil leaching, but we have this whole other issue of soil in terms of agricultural growing, lands, and all over the state and many other states, land spreading, use of compost. So a couple of questions here. One, is this going to be applied to compost that's used across the state? Because I know that the compost here in this town a number of years ago was reclassified as food grade. It used to be non-food grade for many years when we first did this, and somehow a consultant told them how to get more money per ton by making it food grade, which was rather appalling. And it still tests with PFAS. It's still my understanding that anybody who's using biosolids for land spreading and compost from wastewater facilities does not have to test. They test for metals, pathogens, but not PFAS. That's never been added to the panel. What we do know from the research out of Maine and all over other areas of growing is it isn't just the water that crops are getting irrigated with and animals that we eat, are being given as drinking water. It is also from that soil comes grass-fed, chickens that are free ranging, cows that are grass feeding. And we do know that what is used for animal feed does uptake PFOA in particular. That is the source of contamination in all the main farmland. PFOA is number one. So are we going to apply these soil, values and regulatory to agriculture and start looking at, what we can do? Because people do end up with high body burdens from eating meats, chickens, eggs, things that are living on soil and farmland that contains PFAS from land spreading. That is very, very well established. And many crops that we grow and ingest will pass on to us. We do know which ones they are and which ones they aren't. No brainer, leafy greens, water intensive, where you find it, you're gonna have it. So this is a huge issue, for public health. And at the end of the day, it's about contamination, environmental contamination, but it's also about public health. So are there any plans to take these standards and apply them to agricultural uses of compost, land spreading, and start giving some advice and work towards growers, farmers, and even backyard farmers? Because to me, that is very important.
Yeah, so a number of good questions. The regulation of biosolids and sludge falls to another group here at DES, and I know they have been doing testing of sludge from a number of different sources as part of their sludge quality program. So they've been generating a data set on what is in sludge and certain sludge sources and how that has changed over time. I've seen some of those presentations. My understanding is that they're currently working on a leaching study for biosolids, similar to what we did here to evaluate levels that would be protective of groundwater in sludge spreading areas or biosolid spreading areas. In terms of regulation of food supply, that falls to others. DES doesn't regulate food, so I can't really speak to what might or might not be being done on the front of growing food in soils.
In terms of application of the new standard, and Andy Fuller's with us, so maybe Andy, you could just speak to the status of that site across from Saint-Gobain that Jeff was alluding to at 702 Daniel Webster Highway.
Sure, I could say a couple things. I did work closely with Jeff on it too, so there's not too much more to add at this point. But other than we had a there's a property development across the street where they're doing some work, and they have soils that they're not going to be able to use on site, and they have generated a stockpile. And so we've asked sent a letter to Saint-Gobain directing them to address that soil pile. We've given Saint-Gobain a deadline of next week in order to kind of provide us a response. So I don't we haven't had a chance to discuss the contents of that letter directly with them yet. So.
And just looking at the letter, if I'm interpreting it correctly, it was the site owner or the contractor that did the testing of the soil pile that has triggered this action.
Yeah, these types of situations come into us, pretty regularly through development projects, and our general, I guess, response or recommendation to property owners has been to try to reuse soil on site to the extent possible. This situation went a little bit further up I guess, the flagpole because they weren't able to reuse this soil on site. And then also the fact that we do have the recently adopted SRS. We haven't had too many of these situations come up since the SRS went into place in December.
All right.
I would expect it. The only thing I would add is that I would expect this to probably be happening a little bit more frequently now that we have this SRS with property owners as development continues. So this was kind of just the first instance that had come across us. So we have chosen to, we're going to be taking that into discussions with Saint-Gobain on how they plan to kind of deal with this.
Is there some proximity to the Saint-Gobain site where testing would be required or should be required?
Well, technically, I think our opinion would be, like I said, we recommend that all soil try to be reused on site to the extent possible, because it falls upon the property owner to understand the soil that they're moving around, and that if they're not necessarily, it may not be the 600 rules that they would, maybe not trigger, but if it is considered contaminated or mildly contaminated, it actually also falls under, solid waste rules, the 900 rules. So there's a couple different mechanisms, and generally, like a developer or property owner is responsible for making sure they do that work in accordance with the regulations. But right now, I get notified with any, the alteration of terrain is another Bureau of DES, and anytime a permit gets pulled for them for infiltration or soil kind of movement, they'll reach out to me if it's within the 65 square mile area, so that I can take a look at what they're doing and what they're proposing to do at this time.
And I think to expand a little bit in a big picture framework, a number of years ago, we had asked Saint-Gobain to evaluate soil throughout the consent decree area. But I think that was around the time that the new groundwater standards went into effect, and we recognized that exposure to PFAS was primarily through this drinking water pathway. And in recognition of that, we decided to pass on testing of soil at that time, focus full efforts on groundwater testing and getting safe water to folks. But I think now that we've made great strides in advancing identification of wells that are over standard and remedying those in some fashion, I think we now recognize with enforceable standards, it makes sense to revisit that request for investigation of soil quality throughout the area. So that's something we're going to be looking at.
Good to hear. Okay. If we don't have any more questions on this soil remediation subject, Andy, can you update us on the rest of DES goings on?
Sure, absolutely. Good afternoon, everyone. For those that don't know, but my name is Andy Fuller, and I work here at DES and Hazardous Waste Remediation Bureau, and I'm the project manager for the Saint-Gobain Performance Plastics site. To start quickly with an update for the Air Resources Division. As we've indicated before, Saint-Gobain has requested to terminate their permit, but no action has been taken on that request to date. They're going to be required to satisfy all reporting requirements for the permit and submit emission fees prior to that termination. They're obviously at this point no longer they're no longer in operation, so there's nothing for the Air Resources to be permitting. But as far as the Saint-Gobain Performance Plastics facility closure, we were notified in August of 2023 that they would be closing the Merrimack facility. And then in 2024, they removed all equipment and completed their manufacturing operations. October 2024, they had announced their plans to demolish the building located at 701 Daniel Webster Highway. They immediately began work associated with the demolition, including disconnection of utilities, hazardous building material surveys, and abatement of all interior exterior surfaces. Demolition permits for the work were obtained from the town of Merrimack. And as of April 29th, 2025, the roof, exterior siding, and all supporting steel has been taken down, which is now being cut down to size to be shipped off site. So there are no longer any above ground structures remaining at the building, is what we've been informed of. Saint-Gobain's indicated all that structural steel is going to be removed to go off as scrap steel for recycling. Demolition debris from portions of the building significantly impacted by PFAS contamination is going to be disposed or has been disposed of at out-of-state hazardous waste landfill. Their current plan is to remove all the above ground structures and leave only the concrete floor foundation remaining. And as mentioned previously, Saint-Gobain has been scarifying that concrete floor surface to remove surficial contamination, and that was all done before removal of the exterior structure. They continue to indicate to us that all demolition activities will be completed during the 2025 calendar year. I believe they should be wrapping up in Q3. We have been in frequent contact, and we're going to continue to remain in contact through this process, including conducting periodic site visits as the decommissioning continues. For alternate water updates, their contractors, Second Wind, Water Systems, and Culligan Water have been completing POET installations for residents within the consent decree boundaries since late 2022. Approximately 782 properties have been identified under the various term sheet attachments 1 through 24 that have been offered point of entry treatment systems. And as of May 6th, 699 systems have been installed. The remaining properties include those that have either been non-responsive, they could be non-standard installations, or there also could be a few that are more recent notification of eligibility, so their systems haven't been installed yet. For instance, maybe those listed under the last term sheet attachment. Their contractors have been performing periodic maintenance on POET systems to ensure that they're operating effectively. That's in accordance with the work plan that they had submitted to us. And we've requested annual summary reports for the POET system installation and associated maintenance effort. We received a report last April for an update on the POET systems. That was primarily an installation update though. And we are anticipating a new report in May that's going to include the installation effort as well as all the ongoing maintenance. So there's going to be a lot, we're anticipating a lot of sampling results being included in that, and it's also going to document what maintenance has been done at various properties over the last 2 years. As you're aware, the Saint-Gobain's been completing construction work for waterline installations and connection to existing mains within the towns of Litchfield, Bedford, Londonderry, and Merrimack. With the final paving of Hillcrest Road and the town roads in early April, construction associated with the Hillcrest Road water main extension area of Litchfield is considered complete, and Saint-Gobain has discontinued the bottled water deliveries to the 87 properties that are in that area. Their consultant has finalized design packages for the extensions and connections of existing mains in the Merrimack area. That includes the Wildcat, Brenda Lane, and service connections. And they began construction of that late summer 2024. Water main extension, exterior service line connections, and interior meter work has been completed at all 26 properties. And property owners have been notified of that their bottled water deliveries will be discontinued. They indicated that final paving in this area should be completed later in this spring. Their contractors have been completing service connections and existing water mains in Bedford, Merrimack, and Londonderry as well. Those exterior service lines and water meters have been installed at about 54 of 70 properties in those towns. Exterior work has been on hold recently. And the remaining exterior service lines will be installed this month as the roadways have been starting to get reopened for construction, and the interior water meter installation has been continuing. The Saint-Gobain continues to work with the water utility and the town of Londonderry to evaluate the feasibility of water line extensions in that town. We have met with Saint-Gobain, Londonderry, and the water utility multiple times to discuss the expanded water service in that area. Londonderry has been approved for funding through the Drinking Water and Groundwater Trust Advisory Commission. That's to kind of help supplement that project for the town and Saint-Gobain's contribution. And then the negotiations for that project continue. We received periodic updated proposals from Saint-Gobain to remedy additional water supply wells within the consent decree area. Those have been following the initial agreements in April and June of 2022. The most recent was term sheet attachment 24, and that was received and reviewed by DES in March 2025. We anticipate that attachment 25 should be submitted during this month. For the water supply well sampling effort, as I've explained previously, I think Director Wimsatt has too, Saint-Gobain's proposed to conduct the long-term monitoring of drinking water wells under what they refer to as a groundwater management zone work plan, and that is to support the implementation of a final groundwater management permit and the supporting groundwater management zone. In general, this work plan that they're operating under is going to result in approximately 6 samples being collected from all the eligible properties by the end of 2026. Saint-Gobain's been conducting drinking water sampling under this plan since about the end of January 2025. And as of the end of last month, they've sampled approximately 572 properties that were eligible for monitoring under that plan. They've been sampling about 150 to 200 properties per month in order to meet the requirements of the plan, and they're submitting bi-monthly status reports on that sampling effort. As has been in the past, properties that exhibited exceedance of a drinking water standard have continued to be issued bottled water eligibility letters, and they're also identified in the monthly alternate water status reports to DES. Since the start of sampling associated with this GMZ work plan, we've had approximately 66 additional properties that have been identified exceeding the AGQS for PFOA and offered bottled water by Saint-Gobain. So this has been good that we've been able to get this monitoring plan up and going so that we can continue to get some more data for the area. From the site investigation remedial action plan front, the Saint-Gobain had submitted a RAP and a RAP addendum for the site. DES determined that they did not meet the requirements of ENVOR 606, and the deficiencies were detailed in a letter that was sent to them in October of last year. We have since met with Saint-Gobain, and they've indicated they're going to submit a RAP addendum that further evaluates remedial alternatives to reduce contamination at the site. Their consultants identified some data gaps that need to be addressed in order to respond to the DES comments in that letter, and they will be preparing a revised RAP addendum. We don't have a time frame for that. They've indicated to us that they're going to be submitting a work plan to close those data gaps in the second quarter of 2025. So approximately this quarter, and that's going to identify objectives and scope of supplemental investigation that's going to be required for that. That is the report from Waste Management Division. I don't know if there was any questions on what I presented.
Amy.
I have 3 questions. One is, what were the results from the scarification sampling?
We don't have that data back yet, and that is something that we have been asking Saint-Gobain for. It's very difficult, I guess, to correlate exactly what that data means. They have indicated that they've seen a reduction in the concentrations of PFOA and PFAS in the result from removing that 1/8 to 1/4 inch of concrete. I think they've on the order of 30 to 50%, but that reduction. But they haven't provided that to us yet. Like I said, we've asked for it, and we're anticipating getting it, but they're trying to evaluate. They don't have a very good analytical method to understand what that data really is telling us.
So, and follow on to my first question, given that there was a lot of conversation earlier today about self-reporting, I'm wondering how you guys are thinking about validating whatever Saint-Gobain reports for the scarification results. Do you have a sort of protocol in mind that you would use if you were testing the scarification?
No, that's something that's part of our internal discussions. We're going to have to think a little bit further about because again, there's various methodologies that they could be using for sampling the concrete, and then just if the PFAS is in that concrete, it's not sure exactly what that's going to mean for migration to the water table. So we'll be having for sure conversations internally on what we think the best way to interpret that data is. But in the meantime, Saint-Gobain is still trying to figure out what the best way to share that data and to even analyze it. Because as you can imagine, like there's various ways to sample the concrete. crushing up the concrete and doing a method as if it were like soil isn't really representative of the concrete being left out in the open and what it's going to release to the environment. It's there and it tells us what's in that concrete, but not necessarily what sort of additional risk that represents, I guess.
I'm wondering if we could borrow from the methodology that the researchers had used to determine that PFAS can actually penetrate concrete to
It
about
absolutely
12
can.
centimeters.
It can go quite a bit far. I wouldn't, that's a pretty thick concrete slab. So we're not even sure yet what they've got for data, like how deep they've gone into it.
Yeah.
So it's, it's kind of, I guess it's kind of fluid and in work right now.
Okay, so we don't know how far they've gone. The other question, if I may, Chair, is you mentioned that they are sampling 150 to 200 wells per month since January of 2025. What
Yes.
are you seeing in those results? How do you provide that data in any kind of systematic way that shows like how many are over, under?
Well,
What are you
as I
seeing
indicated,
since then?
we had, there's been about 66 new properties that were tested above the drinking water standard. So
Okay,
we're
I'm sorry, I
seeing,
missed that.
so that's about 10% so far. And these are wells that had previously not tested above, because anything that's above kind of falls under a different category of monitoring, and that's the alternate water. Like, so the POET wells, this wouldn't include any well that's got a point of entry treatment system. They're being monitored under a separate work plan. So they're being monitored, but it's a different plan.
So there's 150 to 200 new ones that are showing new exceedances.
No, about 66 is the number right now. That's the new bottled water eligible. So new exceedances is 66.
Okay. And the 150 to 200 per month
That they're
that you're
testing.
testing?
Yeah, because they'll have to collect a couple thousand this year.
Okay, those are the same 150 to 200 that you will test every month.
No, and I know it's a little confusing. I think there's approximately, I'm not sure the total number of wells that are going to be sampled, but in order to sample all of the wells twice in 2025, they have to sample about 150 to 200 per month. So they're going to be going through geographically all these areas. And since January, they've been able to sample 500 and what did I say, about 560 or 570. So they're not even through all of the wells once quite yet. So.
Okay, every well twice through the end of 2026.
Yes.
Is that correct? Okay.
Which should give us 6 samples by the end of that year, which will help us, start building that good data set.
And then, believe it or not, this is my third question. Remind me of the time frame for the Rapidendum. When did the Rapidendum request go in? And it's coming in this month, correct?
No.
The original request for the Rapidendum, well, you said by the end of second quarter, is that? Okay, so 2 months, by the end of June.
So that's going to be the work plan. They're hoping this summer to be doing additional field work and sampling associated with that.
Yeah, and when was the original request for the Rapidendum?
It's been a few years now. I don't have that data in front of me.
I think it's 2 years to this month.
I think so, yeah.
2-year anniversary, okay. Thank you.
Okay. All set, Amy?
Yes, thank you. Thank you, Chair.
Wendy, please.
Thank you. I have a data point for you, and then I have a question. The data point is the property at 10 Wildcat Falls has not been hooked up yet. And I think you reported that all of them have been hooked up. That's my home. They went to hook it up and there was a problem and they ended up flooding our basement. So we have not been hooked up yet. So just for your information. So, but my question about the demolition is, as I drive by, there's a ton of dust and soil being kicked up. I do see, there's a little bit of water being sprayed down on it. I don't think it's sufficient for the property, but who is watching the dust dispersal? Are you doing any testing on that? I mean, are we spreading PFAS further through the demolition? So what about dust?
Well, Saint-Gobain and their contractors would be responsible for doing that in accordance with, proper construction management practices. DES is not doing dust monitoring at this time for the project. I know, as you indicated, I knew from the visits I've had down there, they do have dust suppression mechanisms. They have been driving around the water truck to water down roadways for equipment as it was moving around, but I haven't seen them actually spraying down the building. I think they mentioned it's actually been pretty wet, so they hadn't had to do quite as much, but.
Yeah, thank you.
Jeff?
Yeah, just to follow up on the last question about dust. If folks see dust that's moving off property, there are certain air division rules that govern dust creation. So, I'd recommend contacting our Air Resources Division. They do have inspectors that get out and try and follow up on dust issues. So, if the dust is moving off property, certainly I would urge you to report that to Air Resources, or you could report to Andy, and we could follow with the Air Resources Division. I know that was an issue when there was a prior construction project, around the site, and when I was the project manager. So, recommend you to just let us know.
Gary?
Thank you. This is maybe a topic that we can look at later. But I think both Andrew and Jeff sort of alluded to it. And that's the discussion centered around what comes next. That is, Saint-Gobain is basically the macroscopic problem. The building, the things that we can see and touch that are tangible. But as we know, they're biologically, and we're accumulators. And we've seen that in the past with the DDT with eagles accumulating it, and the problem they had with eggshells. We see it in New Hampshire with loons accumulating lead. And so it begs the question, even though we have MCLs, we've attacked the macroscopic problem, and we have in place POET systems, and they meet an MCL, but we're organisms that bioaccumulate. And we see that in some of the studies that are beginning to come out. There's some autopsy studies that show a fairly significant increase in PFAS materials and nanoparticles of plastics in brain tissue and in kidney. The question is, again, maybe for another time, but are there things that you from the scientific community are aware of in this domain that we can use as follow-up from our macroscopic perspective, so that we can be aware of the microscopic perspective as well? I mean, we see that here already with lead with infants. That's an accumulation. It's not just a single exposure. And similarly, I think what we're seeing, or beginning to see, is the microscopic maybe taking over. Even though we're at the MCL level and feel comfortable with the POET systems, are there more we should be doing?
Jeff?
Yeah, just to speak a little bit to that, I know that's kind of outside of Andy and my expertise, but just having worked on PFAS for a number of years, I came to recognize that these materials are on all sorts of household items, on carpets, furniture, clothing. Unfortunately, we're exposed every day through our daily lives. I think through our regulation of the drinking water and to some extent the soil, limiting exposure through those pathways, but there's a number of pathways, and we have work with risk assessors and toxicologists that may be better able to address sort of the exposure question that you bring up in more of a holistic fashion.
I just thought maybe it's something we should be aware of, and then perhaps as we think about what this commission is doing and should do in the future, what should we sort of rethink or add to what we're doing and what we're thinking in terms of since we've taken the first step, shall we say, and being aware of what the next step should be. But again, it may, as I said, it may be something to delve into further down the road, but I think it becomes an important point.
Okay. If there are no more questions, Nancy, go ahead.
Oh, thank you, Chris. Thank you, Andy, for your report. I just wanted to say I remain very concerned about the concrete foundation at that location, and the striation plan for. I can't imagine that, knowing what we know about PFAS and concrete, that we should feel good about just letting them leave a foundation there. And given the veracity of what we have for information provided from Saint-Gobain, it would compound my concerns about really what we're going to be left with. So I would just ask, as a citizen from this community and as a representative of the citizens from this community, that DES take action to really follow up on that itself, and not rely upon information provided to it that we really, just we would feel better, I think, having the data from DES than information that's provided sort of secondhand to the community. So thank you, Andy, for that update.
Yeah, and the only thing I'll echo is, that it's something that we're paying close attention to. We ask our contact at Saint-Gobain about the concrete sampling and what they're going to do with it every 2 weeks, and it's something that we're not just going to let it go by the wayside. So it is something that we're paying attention to and want to have some of the answers of it. So because that all fits into the conceptual site model that we've been talking about too. What is this going to represent? So we need to have a good idea of that. What they're leaving behind.
Okay. If there are no more questions, we'll turn to DHHS and Michelle.
Sure, thank you. Can you hear me okay?
Yes.
So I'm happy to provide the department's updates for the May meeting here. And so the first, I'll start with the Merrimack cancer investigation. So the team continues to meet monthly with the steering committee, with the last meeting held on May 7th. The discussion at the May 7th meeting was primarily focused on the pilot study, including recruitment and an amendment to the Institutional Review Board, or IRB, submission to allow for the collection of samples from study participants. If you recall, the study has 4 main components. The first component was the community engagement studios and online feedback form. This part of the project is complete. Feedback form still remains live on the department's website, and I'm happy to drop the link into the chat as well. The Dartmouth team regularly reviews comments and questions submitted by community members that have ideas or suggestions related to the feasibility study. The second component is the cancer registry data analysis. That's led by Dr. Salas, and they're working towards finalizing the analysis with feedback from the steering committee and the scientific advisory board. And so the team was informed of an additional data reanalysis requested by the commission that is being completed by the department. And this is for other cancers other than kidney cancer, which will include new VA cases from the New Hampshire State Cancer Registry. To avoid presenting data from different timeframes for kidney cancers and all other cancers, it was decided that the kidney cancer analysis would be redone, adding the outstanding VA cases and any new cases transmitted since December of 2023 from diagnosis years 1995 through 2021. The discussions, this reanalysis and obviously created subsequent work, and it created a little bit of a delay in the project overall, but we're still on track. Since the reanalysis request, Dr. Salas has completed his review of the cases with ambiguous pathology codes with the help of the New Hampshire Cancer Registry and their assistant director, Maria Solea. I hope I'm pronouncing her name correctly. To ensure the proper classification of cases of data. And I know we had some questions on that, and I do have a response from Dartmouth that I'll share in just a bit. The preliminary results through diagnosis year 2021 with the incorporation of the VA cases were part of the presentations that were shared to the two commissions, both this commission and the SB 85 commission as well. The UNH feasibility survey is the third part of the study. The Dartmouth team received the final draft report from the UNH Survey Center, and this will be included in their final report, which they are planning to come back and share the whole final report with the commission as well. And so the remaining component of their study is the pilot study, and the team continues to work on the pilot study through the end of the contract. In alignment with the goals of the overall phase 3 feasibility study, the purpose of the pilot study is primarily to assess the feasibility of a larger study and to generate hypotheses for a future larger study. The pilot findings will be used to help generate hypotheses to be tested in a larger, more definitive future study. The pilot study will not provide definitive information about the causes of excess kidney cancer in Merrimack, but rather it will serve as a preliminary data useful to support a grant application to fund a larger study. The study team received approval from the Committee for the Protection of Human Subjects, CPHS, for the pilot study questionnaire on April 16th. The Community Advisory Board, the Scientific Advisory Board, and the Steering Committee were notified of IRB approval. The Certificate of Confidentiality was approved on April 21st. Advertising and recruitment for the pilot study survey will be the next focus for the study team. The recruitment flyer has been approved by IRB and the DHHS Public Information Officer. The flyer has been sent to the Community Advisory Board, the Scientific Advisory Board, and Steering Committee with the ask that the flyer be shared with any New Hampshire network connections. And I'll also be happy to send along the flyer to the Commission as well. The study coordinator has communicated with members of the Community Advisory Board to get updates about upcoming community events and suggestions about where to post the flyers. Individuals from the Granite State panel, that's the panel that was used for the UNH survey, that provided their contact information to be updated about future research opportunities, have been sent an email to make them aware of the pilot study. The Department of Environmental Services has also sent the flyer to their PFAS list. Posting and oncology clinics, so they're posting the flyer there, and Dr. Tina Bowden has agreed to circulate the flyer through physician networks in New Hampshire. As of May 5th, 36 interested participants completed the eligibility questionnaire, and 30 of the interested participants have lived or worked in the 9-town area surrounding Merrimack. So I know that was a question that you had from last time. How many participants do we have? So we're about a third of the way there right now. The next step in the IRB process involves creating an amendment so that the Dartmouth team can collect samples from the pilot study participants. And based on our meeting just a few days ago, they're anticipating that this will be approved on a short turnaround time for approval on that. So happy to obviously update you on that next month. So that's my update, and I'm going to skip ahead a little bit because one of the questions that was raised during the last meeting was why did Dartmouth focus only on kidney cancers and not renal pelvic cancer? So I was able to get response from them, and I can share that now. So Dartmouth's analysis focused on understanding what was driving the excess kidney cancer noted in the department's Cancer Incident Report, Merrimack, New Hampshire, which was issued in January of 2023. The department's initial report combined renal cell kidney and renal pelvis cancer subtypes together. However, in subsequent follow-up analysis, the department did determine renal cell carcinoma accounted for about 86% of kidney cancers. As Dartmouth noted in their presentation, there are two main subtypes of cancer that occur in the kidneys, and they are found in either renal cells or in the renal pelvis. These two subtypes of cancers are very different, and they're made up of different kinds of cells and have different known causes. Dartmouth wanted to understand if one or both subtypes of kidney cancer were elevated in the Merrimack area, driving the excess level that was previously seen when both subtypes were combined in the department's 2023 analysis. The cancer registry data analysis completed by Dartmouth as part of the study found an excess among cancers originating in renal cells, but not in the renal pelvis. Based on their analysis, Dartmouth is focusing on the renal cell subtype where the anomaly appears to be. So that was their response to the questions that were raised during the last meeting. They are also planning, they're planning to be ready to present their final report and the findings of the Merrimack study at the October commission meeting. So I know that was also a question. And we thought it would be best if both the department and Dartmouth present both the analyses together at that meeting. So if that's agreeable to the commission, you can plan to have the final presentation by both the department and Dartmouth at the October meeting. And the last part of my update is just kind of where we are with the department's analysis of other cancer types. So the department will update the appendix table to the Cancer Incidence Report Merrimack, which was again issued in January of 2023 with the most recent registry data through 2021, including cancer types other than kidney renal cancer in the Merrimack and the 9-town study area combined with the rest of New Hampshire. And the reason for that is because Dartmouth has done the more detailed analysis for the kidney cancer. Current registry data for the years 1995 through 2021 will be used in the analysis. The department is in the process of finalizing the timeframes for the analysis. And the VA cancer data, which became available on February 11th, will be incorporated into the analysis, similar to Dartmouth. And based on the availability of the VA data, we're anticipating having our analysis completed, course at the same time as both the department and Dartmouth will be ready to present all of that information by the fall. And, if we all agree, I can let them know to prepare for the October commission meeting.
Please do.
That completes my summary. I'm happy to answer any questions if I can. And I do have our interim director, deputy director, Whitney Hammond is here as well, if there are any questions.
Do we have any questions? No, I don't see any. So thank you, Michelle. And thank you, Whitney.
Perfect. Thank you.
All right. So I want to circle back to, well, actually, let's do a legislative update, Maureen.
Thank you, Mr. Chairman and members of the committee. One bill to give an update on, that's House Bill 167. That's the bill prohibiting certain waxes that contain PFAS. I know several of the sponsors are on this call. That bill is currently in enrolled status, which is a little bit of a mystery status because we never know exactly where it is in the pipeline. But we do know the next step after enrolled status is the governor's desk. So congratulations to those that helped push that through. Thank you.
Thank you. Okay, and so let's circle back to the minutes that Don Preventer kindly prepared for the April 11th meeting, now that we have a quorum. And I will note abstentions for everyone who's here that wasn't here in the last meeting, so we don't, you don't have to tell us you abstained. Are there any comments or corrections to the minutes? If not, we'll entertain a motion. Motion to approve by Rosemary and seconded by Gary. Any discussion? Seeing none, all those in favor, please indicate, and all set. Okay. Any opposed? I should ask, and I don't see any. We need a minutes taker for the June meeting. So is anybody willing to step up for that? If not, please consider doing that and let me know before the next meeting.
What's the date, Chris, on the June meeting?
The June meeting is the 13th.
I can try to do it. I just, like today, we're having criminal justice meetings on Fridays pretty consistently. So, you know, like today, I barely made it on time, but I'd be happy to do it June 13th. But maybe if we could have a backup person, just in case for some reason I'm in committee.
Okay, Wendy, thank you.
Thank you.
Awesome. And then later on in the year, I think we need October and December, but you know, hopefully by then people will be rested from this legislative session. No public comments that I can see, and unless there's any other business, we'll take a motion to adjourn.
If everybody could just send your presentations to Chris or myself. I have terrible keyboarding skills, and I have the misfortune of being the minute keeper of this lengthy meeting. So send me what you presented, and that will be a tremendous help. Thank you.
Oh, and actually, I wanted to add that last night we saw a presentation by an author who wrote this book. It's about Saint-Gobain and Hoosick Falls, but it also applies to Merrimack. It's just a really good book. It took her 8 years of investigative journalism to write it, and it's just all the background of Saint-Gobain. Really worth reading. It's called "They Poisoned the World: Life and Death in the Age of Forever Chemicals" by Mariah Blake.
Thank you. Thank you, Wendy. All right. Anything further? If not, we'll take a motion to adjourn.
So moved.
Motion by, I think by Wendy, seconded by Laureen, and Nancy, you're an honorable mention. All those in favor, please say aye. Aye. Okay. Thank you very much. Happy Mother's Day to all of you who are mothers. Thank you.
To all who have them.